If Earth were to hit the reset button, would life appear again? If you were on the scene 4.5 billion years ago, looking at a magma world, more hellish than hell itself, you'd wonder how life could possibly be born here. But the universe made an exception for Earth. Was it a glitch, a deliberate act, or just a pure accident? Hello, Earthlings. Welcome. You are about to witness a 4 or 5 billion year epic accident. If you stood on Earth back then, there were no blue skies or white clouds, just a molten ball with temperatures exceeding 1,200 C, lava sphere. The air was filled with suffocating toxic gases. Surviving even a second here would be a miracle. Yet, this cosmic Breaking Bad scenario eventually gave birth to you and me. Today, I'll take you through 4.5 billion years to see with your own eyes how Earth went from hell mode to clearing the game and creating humanity. Let's rewind to 5 billion years ago. Back then, there wasn't even a shadow of Earth. Only the newly born sun and cosmic dust dancing everywhere. You'd never guess that. A planet as complex as Earth initially relied on gravity to forcefully glue rocks and dust together. After sticking together for millions of years, a ball of rock finally took shape. 4.54 billion years ago, Earth officially went online. But this starter village map would make any player quit immediately. Welcome to New Earth. Here we have oceans of liquid lava at 1,200 C. No solid ground. No oxygen. And it comes with a continuous meteorite bombardment package. But the real thrill is coming up. A planet the size of Mars is rushing straight toward Earth at 15 kilometers per second, 20 times faster than a bullet. This collision was the solar system's most tragic car crash. Earth was cracked open, blasting trillions of tons of debris into space. But the magic of the universe is that destruction is often creation in disguise. Under gravity, that debris ray aggregated around Earth in just 1,000 years. And just like that, the moon was accidentally born. Back then, the moon was only 20,000 kilometers away, appearing incredibly huge in the sky. This impact also sent Earth spinning like a crazy top. It spun fast. A day lasted only 6 hours. Fast forward to 3.9 billion years ago. Earth was still being bombarded by meteor showers. But this time, they didn't bring destruction. They brought the ultimate code for life: water. Inside those meteorites, scientists found tiny crystals and water molecules. Over a period of 20 million years, these cosmic delivery drivers kept dropping off goods. Countless droplets gathered to form Earth's first puddle. And then the first ocean. Every sip of water we drink today is billions of years old. It traveled millions of kilometers through space to be delivered via meteorite. Once Earth finally had water, the script for life truly turned its first page. But wait, the early Earth was still a chaotic training ground. Superstorms, kilometer-high megatides. If life wanted to start here, it had to survive another brutal round of elimination. When Earth gained oceans, the stage was set. Underwater volcanoes erupted constantly. Lava cooled to form islands, which would become the first cornerstones of future continents. But the real miracle happened 3.8 billion years ago. Those meteorites continuing to hit Earth brought something more precious than water: the building blocks of life: carbon and amino acids. These basic units of life were delivered by meteorites from outer space directly into the deep ocean. In the freezing depths where sunlight couldn't reach, another revolution was happening. Cracks in the crust spewed scorching, mineral-rich fluids. They formed submarine chimneys. Chemicals brought by meteorites mixed with these hydrothermal fluids, turning the seawater into a rich chemical soup. In this soup, Earth's earliest life, single-celled bacteria, was born. However, for the next few hundred million years, life seemed to hit the pause button. There were only these simple bacteria. No complex organisms appeared. Until 3.5 billion years ago, a turning point occurred in a shallow sea. Strange structures, resembling small forests of rocks, appeared. Stromatolites. They were actually skyscrapers built by bacteria. And these bacteria mastered a magic that would overturn the world: photosynthesis. Like tiny chefs, they used sunlight, carbon dioxide, and water to cook up Earth's first sugar. The byproduct of this process was oxygen. At first, the oxygen quietly dissolved into the ocean, turning dissolved iron into rust, which sank to the bottom, forming the iron ore we use to make steel today. But gradually, oxygen began to escape the ocean and transform the atmosphere. With every breath we take, we should thank these ancient bacteria. They spent 2 billion years silently charging Earth with oxygen. Meanwhile, Earth's rotation slowed down, extending the day to 16 hours. The progress of life required unimaginable patience. Time advanced to 1.5 billion years ago. Earth had been spinning alone for 3 billion years. Looking around, there were no plants, no animals. The world was terrifyingly quiet, but beneath the silence, a force powerful enough to reshape the world was waking up. Earth's skin was moving. Heat from the core pushed the crust apart, carrying huge plates that held the precursors of the continents. After 400 million years of drift, Earth's first supercontinent, Rodinia, finally formed. Suitable temperatures, 18-hour days, and an oxygen-rich atmosphere, everything was ready, waiting for life to take the stage. But fate played a cruel joke on Earth. 750 million years ago, Rodinia began to break apart. Heat from the mantle tore the crust open. Carbon dioxide spewed by volcanoes was absorbed by the newly exposed rocks. Greenhouse gases in the atmosphere dropped drastically. Earth's insulation blanket vanished. Temperatures plummeted to 50 degrees in just a few thousand years. From the equator to the poles, ice spread unstoppably. The white surface reflected sunlight back into space, making Earth colder and colder. Eventually, ice sheets 3 kilometers thick wrapped the entire planet tightly. Earth became a dead ball of ice. During 15 million years of deep freeze, volcanoes never stopped erupting. Since rocks were covered by ice, they couldn't absorb carbon dioxide. The gas accumulated in the atmosphere, wrapping Earth like a thick blanket again. The greenhouse effect quietly restarted. The ice began to melt. Even more amazingly, chemical reactions during the freeze created massive amounts of oxygen. When the glaciers melted, this oxygen was released, paving the way for complex life. From scorching hell to frozen planet, then to a cradle of reviving life, Earth proved with its history that life's resilience is beyond imagination. And what was coming next would be an explosion of life that would change the world forever. Music. 600 million years ago, temperatures rose, days lengthened to 22 hours, and oxygen-rich oceans prepared perfect conditions for life. Shockingly, those primitive bacteria actually survived a freeze 75 times longer than human history. They evolved silently in the deep sea, waiting for their chance. 540 million years ago, the ocean changed completely. The once monotonous water world suddenly became a live broadcast of an underwater Hunger Games. Armored Wiwaxia crawled on the seabed. Trilobites patrolled like tanks. They would become the ancestors of future insects and scorpions. The top predator of the time was the 60-centimeter-long Anomalocaris, with huge eyes, razor-sharp teeth, and grasping limbs. It was the max-level boss of the ancient ocean. But the most crucial character was hiding in the corner. The tiny Picaya, just a few centimeters long. It had a humble strip of cartilage inside, which would become the blueprint for the spine of all vertebrates, including humans. Just when we expected to find ruins, we found the wildest underwater party in history. But a bigger question followed. With the ocean so lively, what about the silent land? Was incredible life also quietly taking root there? 460 million years ago, the land was still dead silent. The continent of Gondwana below had a mild climate, suitable temperatures, and sufficient oxygen. Yet there were only scattered algae, no real vitality. Deadly solar radiation blasted the surface like death rays, turning the land into a forbidden zone. But a turnaround was quietly happening high above. Oxygen met solar radiation 50 kilometers up. Chemical reactions created ozone. After 120 million years of accumulation, this sunscreen for Earth finally became thick enough to filter out deadly radiation. Protected by the ozone layer, the final barrier was cleared. The earliest pioneers, moss-like plants, finally took root on the new land. They didn't just stand their ground. They started releasing more oxygen, paving the way for complex life to come ashore. 375 million years ago, a fish made a decision that changed the world's fate. It tried using its fins as legs and poked its head out of the water. This was Tiktaalik, our true programmer ancestor. In its fossils, scientists found a shocking secret. It had a movable neck and skeletal structures resembling limbs hidden in its fins. This bizarre half-fish, half-beast became the key that opened the door to the land. After 15 million years of evolution, these tetrapods developed stronger limbs and spent more time out of the water. Until 360 million years ago, they bid farewell to the water completely and made the land their new home. starting with that fish struggling onto the shore. The saga of all land vertebrates. Dinosaurs, birds, mammals, and eventually as humans officially began. Earth, 360 million years ago, was like a kingdom built for giants. Imagine dragonflies the size of eagles, screaming overhead, 2-meter-long millipedes winding beneath your feet, wolf-sized scorpions patrolling fern forests, wolf-like scorpions patrolling the fern forests. This was Earth's age of giant insects, thanks to off-the-charts oxygen levels. The respiratory systems of these prehistoric bugs were highly efficient, allowing them to grow to incredible sizes. Meanwhile, on the ground, a quieter revolution was complete. The appearance of the first seeds allowed plants to pack their own lunch and expand endlessly inland, far from water. Tall fern forests released even more oxygen, creating the perfect environment for complex life. In this forest ruled by giant insects, a small creature named Hylonomus brought a world-changing invention. But this self-contained, aquatic environment full of nutrients and water freed its offspring from dependency on bodies of water. From then on, the final shackle holding animals back from conquering the land was broken. This unassuming little lizard was the pioneer for all reptiles, including future dinosaurs and the ancestors of humans. After giant insects ruled for 300 million years, another revolution brewed deep underground. Countless dead plants piled up, layer by layer, under high heat and pressure. They quietly transformed into black ancient solar batteries. Coal. Every piece of coal we burn today holds the life energy of forests from 300 million years ago. While future energy was accumulating underground, the Siberian plains were hosting a thrilling battle for survival. 250 million years ago, dinosaurs hadn't appeared yet, but the land was occupied by giant reptiles. Tank-like Scutosaurus were grazing on vegetation. They were distant relatives of turtles. However, danger arrived quietly. A Gorgonopsid, the prehistoric apex killer, was lurking nearby. Its deadly fangs had already severely wounded its prey. Now, it calmly waited for the prey to bleed out and fall. This perfect killing machine represented the pinnacle of evolution at the time. Just as these predators thought they ruled the land, they had no idea that the ground beneath them was brewing a disaster that would reset the entire world. A heat wave from deep underground signaled that this planet was about to face its darkest hour. Strange things were happening. The ground was heating up. There must be immense pressure beneath the surface. It's lava, but this wasn't an isolated volcano. The entire landscape was erupting. A massive mantle plume rose from the deep earth, pushing lava through cracks in the crust. This lush paradise was turning into a lifeless hell. Just as these predators thought they ruled the land, a true catastrophe had quietly arrived. On the other side of the continent, snow fell in 20°C weather. It was actually volcanic ash from eruptions, 16,000 kilometers away. This deadly dust blocked the sunlight and turned into sulfuric acid rain, corroding everything on land. And this was just the start. Volcanoes continued to erupt. Carbon dioxide levels skyrocketed. Global temperatures surged. Oceans lost oxygen in the heat and turned an unsettling pink color. The once thriving water world now only hosted heat-loving pink algae. The deadliest killer had just awakened. Methane, a greenhouse gas 20 times more potent than carbon dioxide. It spewed from the melting seabed, pushing global temperatures to a terrifying 40°C. Creatures that once dominated Earth fell one by one. During this 500-year hell mode, 95% of life was completely wiped out. The clock of evolution was forced to reset. Earth, the blue-green planet that had just blossomed, turned back into a lifeless purgatory. 500,000 years had passed since the first eruption. For 500,000 years, lava had been pouring out. By now, it covered an area the size of the United States. The lava layer was nearly 6 kilometers thick. 95% of life was annihilated. Only a few creatures survived by burrowing and eating anything. This mass extinction reset the evolutionary clock. 250 million years ago, we were back to the starting line, back to a lifeless planet. Almost 50 million years passed since the devastation. Earth had changed dramatically. It was now 200 million years ago. There was only one supercontinent, Pangaea, stretching from pole to pole. After the trauma of the Great Dying, Earth was healing. Temperatures stabilized. Acid rain was neutralized, and vegetation was returning. The elimination of 95% of life opened the door for a new species to emerge. A species that would dominate the planet like never before. The dinosaurs. These are called Plateosaurus. Like all dinosaurs, they evolved from the few reptiles that survived the mass extinction. They were 4.5 meters tall. Their size made them slow and vulnerable. These are two Dilophosaurus. They were small, fast. One Dilophosaurus couldn't handle a Plateosaurus, but two could. Dinosaurs had conquered Earth, but no species could tame this restless, volatile planet. The crust was thinning, releasing lava, accompanied by earthquakes. It was as if an invisible force was stretching it. The same thing was happening on the future east coast of North America. Earth's plates were moving again. 190 million years ago, the massive Pangaea was breaking apart. A huge chunk of land had broken off, forming a new ocean, the Tethys Sea. Located in what is now the Middle East, currents pushed nutrients into coastal waters. These nutrients attracted millions of fish. Where life thrives, death follows. Dead fish and plankton carpeted the seafloor. Over the next 10 million years, rock layers buried and heated them. Ancient fish and plankton turned into oil. Every liter of gas in our cars, every piece of plastic on Earth, the paint on the walls, the carpets underfoot, even the soap we wash with originates here. 180 million years ago, further west, the North American plate was moving away from Eurasia. The process was slow, about 2.5 centimeters per year, roughly the speed our fingernails grow. But fast forwarded, we can see a new ocean forming beneath our feet, and new continents. Montreal moving away from Marseille, New York moving away from West Africa. The world as we know it was taking shape. The rift between continents filled, creating a massive ocean, the Atlantic. And in the middle, a volcano. We've seen plate movement before, and know it's caused by currents deep in the crust. That process is happening right there now. The entire seabed was torn in half, pushed up into a ridge of mountains and volcanoes. Higher than the Himalayas, longer than the Rockies. The water here was hot, lava spewed from the deep earth. As the lava cooled, it created volcanic ranges and new ocean floor. Over millions of years, this process pushed the plates, tore Pangaea apart, and reshaped our world. This geological activity kept Earth alive, making creation unique. Every time the planet reinvented itself, the creatures living on it had to adapt and evolve. Like these, they are ichthyosaurs. Their reptile ancestors lived on land. But as Earth changed, they changed too. They grew fins and moved into the newly formed Atlantic. At 6 meters long and very fast, reaching speeds of 40 kilometers per hour. It was the fastest creature in the ocean, the most efficient predator. It ruled Earth's oceans for 50 million years. But now, a new contender for the throne appeared. The pliosaur, longer than a bus, heavier than a truck. Its jaws were immense, with a bite force 8 times that of a great white shark. Teeth at least 30 centimeters long. Earth and the life on it had become unrecognizable. This was once solid ground. Now it's the Atlantic Ocean, right where we are standing. We once watched Plateosaurus grazing and Dilophosaurus prowling. The dinosaur world may have changed, but they still held dominance. They seemed invincible. 65 million years ago, they were one of the most successful species on Earth. They survived volcanoes, earthquakes, and the splitting of continents. Dinosaurs had thrived for 165 million years, but nothing is invincible. Just like when we are in bed, wanting to finish the story of Earth, but afraid the phone will stay on all night if we fall asleep. You can try soda music in the bottom left corner. It's listen to TikTok mode, plays while locked, and has a sleep timer. Guaranteed you won't miss the next little guy entering the stage. It was a mammal. It evolved from the few mammals that survived the extinction 185 million years ago. It was also dinosaur prey. That's why most mammals lived in trees or underground, only coming out at night. Mammals pose no threat to dinosaurs. Nothing could challenge their dominance. Nothing on Earth could do it. But a space rock could. A very big rock. This asteroid was 10 kilometers in diameter, bigger than Mount Everest. It was heading for the Gulf of Mexico, near the Yucatan Peninsula. It happened too fast. Blink, and you'd miss the impact. Unless we slow down time. This would be the moment the world changed. Even at the moment of impact, the back of the asteroid was still at 11,000 meters altitude. cruising high for commercial jets. The asteroid struck with immense force, destroying everything it touched. Even the asteroid itself vaporized instantly. This impact released the energy of millions of nuclear weapons. Nowhere was safe. Even here, high in the sky, these boulders, some the size of city blocks, are shrapnel from the impact zone spreading via shockwave. Minutes after impact, thousands of kilometers away, Earth was under attack from all sides. Boulders fell like rain. Earthquakes shook the ground. Tsunamis battered the coasts, but this was just the beginning. A plume of lava and dust spread to engulf the entire planet. The sky became one giant heat lamp. Earth's surface temperature hit to 75 C. Vegetation spontaneously combusted. Even months later, smoke and ash still blocked the sun. Without sunlight, plants died. Animals that ate them starved to death. Facing this apocalypse, it was hard to imagine any creature surviving. 65 million years ago, dinosaurs suffered blasts, famine, and fire. Their 165 million year reign was over. But the dinosaurs' demise gave another species an opportunity. Mammals, by living underground, they escaped the heat and fire. By eating anything, they thrived while picky eaters perished. These unlikely heirs to the throne took over the dinosaurs' kingdom. One story ended, another began. This would be our chance, our time. Would the next chapter belong to us? With dinosaurs gone, Earth was peaceful. In this new world, our mammal ancestors were evolving. 47 million years ago, this lake in future Germany was the perfect place to find them. It didn't look like previous mammals. Its eyes and brain were bigger. This is Darwinius macilli, or Ida. It looks nothing like us. But fossil evidence tells us these creatures would evolve into monkeys, apes, and eventually humans. We are looking back 47 million years, tracing back to potentially one of our earliest known ancestors. This lake sat atop a volcanic crater, spewing toxic gas. The lake that killed her preserved her in its oxygen-free depths. One day, when the lake dried, and Ida turned to fossilized stone, we, her descendants, would find her and recognize ourselves in this primitive primate. The beginning of the story of human life. We are one step closer to understanding how everything we've seen, from ocean bacteria to walking fish and burrowing rodents, led to us, and understanding how our planet was formed. 47 million years ago, the atmosphere was very similar to ours now. Temperature was 24 C. A day was nearly 24 hours. The Earth we see now was almost exactly the planet we call home. Almost. Earth's plates moved again, carrying continents. This time India moved north, toward Asia. The Indian and Asian plates locked in a colossal struggle. Neither plate gave way. Both began to buckle. The former seabed was thrust upward along a 2,400 kilometers fold belt. A massive range rose, 1,500 meters high, 4,500 meters, now over 8,000 meters. The Himalayas. There stands the highest peak, Mount Everest. Its summit pierces the stratosphere. Cruising altitude for jets. When snow on the peaks melts, it feeds great rivers. The Ganges, Indus, Yangtze, and Yellow River. The Himalayas act as a giant water tower. One day, these rivers will provide water for nearly half the world's population. 20 million years ago, this was our planet. Every continent, every ocean was as we know it. Only one thing was missing: humans. For humans to evolve, something somewhere had to change. Along the east coast of Africa, between crustal plates, a massive rift valley was forming. 4 million years ago, this rift stretched nearly 6,000 kilometers. Along its edge, mountains were rising. Look, that looks like an ape. Not a human. They might have stayed in those trees forever, but their world was changing. The rising mountains acted like a stone wall, blocking moisture from the Indian Ocean from crossing the land. It got hotter and drier. Lush rainforests turned into arid savannas. The new hotter climate destroyed their habitat. This forced them to search further for food. Instead of knuckle walking like apes, they stood up and walked on 2 feet. This was the most important step in human history. This mountain range on the east coast of Africa might be why we walk on 2 legs. It seems incredible. Random plate movements triggered a chain of events that eventually led to the emergence of the first humans. A man and a child. This could be a scene from our time. But this was 1.5 million years ago. These were early human species, called Homo erectus. These are the first footprints in history, just like ours. Our journey is almost complete. But our ancestors still had a journey to finish. Out of Africa, the climate changed again. 70,000 years ago, sea levels dropped. The gap between Africa and Arabia shrank to just 13 kilometers. The Red Sea became narrow and shallow enough for this small group to cross. Out of Africa, this was a later human species called Homo sapiens. They made the crossing. Scientists believe everyone outside Africa descended from these roughly 200 individuals. Over time, our ancestors multiplied and spread to India, Asia, and Europe. But as humans migrated north, a giant wall of ice was creeping south. It seemed our planet and the life on it were about to clash head-on again. 40,000 years ago in Europe, our Homo sapiens ancestors arrived here, only to find the world changing fast. It was getting colder. In what should have been summer, plants were frosted over, and rivers froze. Natural changes in Earth's orbit, CO2 levels, and warm ocean currents combined to lower Earth's temperature. Earth and its inhabitants were entering an ice age. About 20,000 years ago, the ice stopped moving. Much of the northern hemisphere was covered by ice sheets 2.5 kilometers thick. A strip of land emerged from the ocean between Siberia and Alaska. It was a bridge connecting 2 continents, a gateway leading humans from Asia into a new world. It is now 14,000 years ago. As the glaciers retreated, they revealed a very different northern hemisphere. 6,000 years ago, ice retreated to the poles. After a 4-5 billion year journey, this is our world, our time. From the sky above us, to the essential element of life, water, to the ground beneath our feet, and life itself, the spectacular result of a chain of accidental disasters and coincidences. But Earth's story hasn't ended here. Much has happened, but there is more to come. Earth will exist for at least another 4.5 billion years. What wonders lie ahead? What terrors? What strange creatures are waiting? As for the next chapter of Earth's story, it is waiting to be written by the future.